Okay, we look into power of accommodation. First, let me read the text. The eye lens is composed of a fibrous jelly-like material. Its curvature can be modified to some extent by the ciliary muscles. Okay, here you need to keep in mind, earlier I told you that the eye lens, right? The eye lens is what? The eye lens is a convex lens, right? It is convex lens, but don't think that the lens in our eye is that of glass or anything as such, but it is made up of what? It is made up of fibrous, okay, fibrous, fibrous, fibrous jelly-like materials. Jelly-like materials. This is very important, okay? The eye lens is made up of fibrous jelly-like materials. Okay, eye lens is made up of fibrous jelly-like materials. Its curvature can be modified. You know, it's spherical. I would rather say that it's more or less spherical. But this shape of the eye lens, okay, the spherical shape of the eye lens can be modified by what? Can be modified by the ciliary muscles. Okay, very important. They are, as it is mentioned in the book, its curvature can be modified to some extent by the ciliary muscles. The change in the curvature of the eye lens can thus change its focal length. Very important, right? Very important. We are coming to a very important point, and the point is change in the curvature, right? Change in the curvature can change what? Can change the focal length. Now, this is one area where you have to concentrate. Change in the curvature can change the focal length. Once again, I'll read. The change in the curvature of the eye lens can thus change its focal length. Please keep in mind change in focal length. That word you keep in mind. Why the change is important, I'll let you know. When the muscles are relaxed, the lens becomes thin, thus its focal length increases. This enables us to see distant objects clearly. Very important point once again. When the muscles are, okay, when the muscles are relaxed, right? When the muscles are relaxed, the lens becomes thin. So we are coming to another important point. When the muscles are relaxed, the lens becomes thin and the focal length increases. This enables us to see distant object clearly. When you are looking at objects closer to your eye, the ciliary muscles contract. This increases the curvature of. Okay, so before I go to that, uh, when the muscles are relaxed, the lens becomes thin and the focal length increases. Now, when the focal length increases, what happens? When the focal length increases, in this scenario, okay, in this scenario or in this situation, when the muscles are relaxed, okay, the lens becomes thin and the focal length increases, because of which, when this happens, when the eye muscles are relaxed, okay, and the lens becomes thin, the focal length increases. In this case, what happens? In this case, you are able to see distant objects clearly. In such a situation, you will be able to see what? You will be able to see distant objects, okay? You will be able to see distant objects clearly. Very important. So here, when the muscles are relaxed, the lens becomes thin, the focal length increases, because of which you are able to see the distant objects clearly. Situation 1. Now here the muscles are relaxed, okay? Now the second scenario or the second situation is when muscles contract, when eye muscles, okay? When eye muscles contract, the eye lens, what happens to the eye lens? When you are looking at object closer to the eye, the ciliary muscles contract. This increases the curvature of the eye lens and the lens become what? The eye lens becomes thicker and the focal length, okay, the focal length decreases, right? The focal length decreases. Now in this situation, what happens is you are able to see nearby objects. What? To see nearby objects, you are able to see nearby objects, okay, nearby objects clearly. Now, as you remember that we are discussing about power of accommodation. So before directly going into the definition of power of accommodation, here I want to tell you that in case of our eye, there are two things happening. Okay, remember the ciliary muscles. Okay, ciliary muscles. Now, when the ciliary muscles relax, okay, the two muscles at the end of the eye, when those muscles relax, your lens, the curvature of the lens becomes thin, or the lens gets thinner. When the lens gets thinner, the focal length increases and you're able to see distant objects clearly. Again, the second case. When muscles contract, the lens becomes thicker and the focal length decreases. Okay. When the lens gets thicker, the focal length decreases, because of which you are able to see nearby objects clearly. Now, this ability of the eye, okay, this ability of the eye by which you are able to see the nearby objects as well as far away objects clearly is what we call it as power of accommodation. Now, let me give you a small example. If you want to see a faraway object, you need not go close to that object. Even from a distance, you are able to see clearly, provided your eyes is normal. If you want to see a nearby object, you don't need to go closer to that object. You are still able to see it clearly. Now, this ability of the eye to see faraway objects as well as nearby objects clearly is what we call it as power of accommodation. Here, a very important point for you to remember is the eye is able to see the nearby objects clearly as well as far away objects clearly by increasing or decreasing the focal length. And how the focal length increases or decreases, it depends on whether the muscles are relaxing or the muscles are contracting. Okay, so now we come to the definition. The ability of the eye lens to adjust its focal length is called accommodation. I would rather add something else there. The ability of the eye lens to adjust its focal length, because of which the eye is able to see far away objects as well as nearby objects clearly, is what we call it as power of accommodation. However, the focal length of the eye lens cannot be decreased below a certain limit. So over here the focal length increases, and here you need to remember the maximum distance at which you can see things clearly is infinity. Okay, the maximum distance at which you can see things clearly is infinity. Whereas the nearby, what is the minimum distance at which you can see an object clearly? Please keep in mind, you just take anything very close to your eye, you will see that you will find that you are not able to see it clearly. So the minimum distance at which you can see an object clearly is at a distance of 25 centimeter from the eye, right? 25 centimeter. The minimum distance, right? The minimum distance at which an object can be seen most distinctly without strain is called least distance of distinct vision. Here, if you see here, this is just, let's assume that this is the eye and this is the object, right? Now the minimum distance at which an object, in very simple language, if I am to tell you how far, or let's say how close can you keep an object how close can you keep an object to your eye so that you can see it clearly? Remember, it should be 25 centimeter. If you bring the object closer to the eye less than 25 centimeter, okay, less than 25 centimeter, you will not be able to see it clearly. Now this is what we call it as least distance of distinct vision. Least distance of distinct vision. What do you understand by least distance of distinct vision? The minimum distance at which the eye can see things clearly. The furthest point up to which the eye can see objects clearly is called far point of the eye. Now another one is far point, right? Far point of the eye. So what do you mean by far point? Far point means how far from the eye, how far should an object be from the eye so that the eye can see it clearly. Okay, the farthest point, and that is what? That is infinity, right? The least distance of distinct vision is 25 centimeter, and the furthest point is infinity. Okay, so Sometimes the crystalline lens of the people at all age becomes milky and cloudy. This condition is called cataract. This causes partial or complete loss of vision. It is possible to restore, right, the vision through cataract surgery. Now here, uh, now over here, this is a problem of the eye, cataract. Okay, what do you mean by cataract? Let's say if this is the iris, okay, this is the iris and this is the pupil, right? The outer portion is the iris and the inner portion is the pupil. This problem of cataract, you will find that it normally takes place or it normally occurs in old people, okay, in old people. Now, what happens in cataract? I'm sure you must have seen. In order to explain this, what I can do is, you will find that gradually, okay, with age, what happens is, this is the pupil, and this pupil is very important. Why? Because light has to enter through it. Light enters inside the pupil, and when light enters, then only you are able to see things. You're able to see things, okay. But with old age, what happens is there is a white, okay. Let me put it with some other color. Gradually, as people get older, right, as people get older, it may not be there in all cases. You don't find that everybody who is old will have this problem, but there are people who suffer from this. Now in this one, what happens is this pupil is normally supposed to be black in color, but gradually you will find that on top of this pupil a white growth takes place, right? That means that white growth is normally what happens is it gradually covers the entire pupil if care is not taken. That means the whole pupil, which is supposed to be black, is covered by a white growth, right? Now when that happens, what happens is light cannot enter, right? Light cannot enter, and gradually the person will not be able to see anything. Now that problem, okay, that problem where you find that white growth on the pupil is what we call it as cataract. Fortunately, it is a problem which has a solution also. If this can be corrected, right, this problem can be corrected by surgery, okay. So that is why you'll see sometimes the crystalline lens of the people at old age becomes milky and cloudy. This condition is called cataract. This causes partial or complete loss of vision. It is possible to restore vision through a cataract surgery. Okay, first problem of the eye. Defects of vision and their correction. Now here, defects of vision. What do you understand by defects of vision? Uh, you will find, okay, you will find that there are people who suffer from the inability to see nearby objects clearly, or maybe there are some people who cannot see far away objects clearly, okay, or there are some people who can neither see nearby objects clearly nor they can see far away objects clearly. So normally these are the defects of vision, right, which you might have heard of. It is called as what? Normally, there are three common defects of vision. These are myopia or nearsightedness, or we also call it as short-sightedness. We call it as the second one is hypermetropia or farsightedness. Okay, so what are the three defects of vision, or what are the defects of vision that we will be discussing on? One is myopia, right? Myopia, or it is also called as what? Nearsightedness. Nearsightedness, right? This is also called as what? This is also called as short. This is also called as short-sightedness, right? The second one is right? Hypermetropia. Hypermetropia, or we also call it as far-sightedness. Okay, far or long-sightedness, right? And the third one, okay, the third one is called as presbyopia, right? Presbyopia. Okay, these defects can be corrected by, okay, so in there may be other problems also, but normally over here we are going to discuss only on these three issues. Okay, three defects of vision. One is called as the myopia or nearsightedness, that is also called as short-sightedness, hypermetropia or called as far-sightedness, and presbyopia. Let's look into all these three defects of vision. Before we discuss into the defects of vision, first let us see what is a normal eye. Okay, let us suppose that I am drawing an eye, right? Here you have the lens. Now this over here is the retina. Okay, this is the retina, this is the lens. When a ray of light, okay, when a ray of light comes from an object, when a ray of light comes from an object lens, so it will undergo refraction, right? When a ray of light comes from an object lens, so it will undergo refraction. Now what do you see? In case of a normal eye, the rays of light meet where? Meet on the retina. And this is very important. In case of a normal eye, the rays of light meet on the retina, and if the rays of light from the object meet on the retina, it means that that eye is normal and the person will have no problem in seeing far away objects or nearby objects clearly, right? Whether it is short-sightedness or long-sightedness, or we also call it as myopia or hypermetropia, in those what happens is the ray of light, instead of meeting on the retina, they will either meet, okay, they will either meet in front of the retina, or they will meet where? They will meet behind the retina. These are the two problems. Okay, remember, for a normal eye, the rays of light coming from an object meets where? For a normal eye, the rays of light coming from an object meets at the retina. So when does the problem start? The problem start if the rays of light coming from an object does not meet on the retina, but instead meets in front of the retina, or meets where? Meets behind the retina, right? So keep this image in mind, that for a normal eye, the rays of light meets where? Meets on the retina, and if the rays of light meet on the retina, the person will have no problem in seeing far away objects clearly or nearby objects clearly. Okay, now let's discuss about the first defect of vision, right? The first defect of vision, which is also myopia or nearsightedness or short-sightedness. Let me read it for you. Myopia is also known as nearsightedness. A person with myopia can see nearby objects clearly but cannot see the distant objects distinctly. I think that should be very, very clear. Okay, myopia is that defect, okay, is that defect of vision in which uh, a person with myopia can see nearby objects clearly, right? Can see, myopia, can see what? Can see nearby, right? Can see nearby objects, okay? Can see nearby objects clearly, but they can see nearby objects clearly, but far away objects, far away objects, it's not clear. Okay, far away objects is not clear, or it is what? It is blurred, right? Cloudy, or whatever you call it, right? So what is myopia? Myopia is that defect of the eye in which a person can see nearby objects clearly but cannot see distant object clearly or distinctly. Now, what happens in myopia? A person with this defect has a far point nearer than infinity. Such a person may see clearly up to a distance of few meters. In a myopic eye, the image of a distant object is formed in front of the retina and not on the retina. Very important, right? If you remember, the normal eye, the rays of light meet on the retina, but in case of, okay, let's say this is the eye, okay, this is the eye, and this is the retina, this is the lens. In case of a myopic eye, the rays of light coming from an object, right, the rays of light, now you see, this is the problem. In case of a myopic eye, the rays of light coming from an object, right, meeting point, MP, meeting point. In case of a myopic eye, before that, you know that for a normal eye, the rays of light should meet where? Should meet on the retina. But what is happening here is, in case of a myopic eye, the rays of light coming from an object, instead of meeting on the retina, they meet where? They meet in front of the retina. And that is what is very clearly mentioned in the book also. See, in a myopic eye, the image of a distant object is formed in front of the retina and not at the retina. This defect may arise due to excessive curvature of the eye lens or elongation of the eyeball. So, what are what is the problem with why myopia takes place? Number one, excessive, right? Excessive curvature. That means the eye lens is curved too much. Okay, excessive curvature, right? Excessive curvature of eye lens, right? It can be because of excessive curvature of eye lens. And number two is it is also elongation of the eyeball. Elongation of the eyeball. Elongation of eyeball. Keep in mind, what are the two causes of myopia? The two causes of myopia can be one, excessive curvature of the eye lens, right, or elongation of the eyeball. Excessive curvature of the eye lens means the eye lens is bent more than normal. Okay, so let's say just to make it clear to you here, I hope you can see here. If this is the normal eye lens, okay, right, if this is the normal eye lens, what happens is, if this is the normal eye lens, now there is excessive bending, right? There is excessive bending. The eye lens is curved too much, excessive curvature of the eye lens, elongation of the eyeball, right? This defect can be corrected by using a concave lens of suitable power. This defect can be corrected by using concave lens. So, very important point, very important point. Myopia, right? Myopia can be corrected by using what? Myopia can be corrected by using concave lens of suitable power, right? Concave. Myopia, the correction of myopia is concave lens. Now, what happens when you put on this lens? Okay, what happens when you put on this lens? What was the problem? The problem is the problem is the rays of light are meeting in front of the retina. Okay, now so we have found a solution to this problem of myopia, and for that what you need to do is you need to use a concave lens, right? When you put on a concave lens, right, when you put on a concave lens, you find that concave lens is what? Concave lens is a diverging lens. So a ray of light coming from an object passes and then it diverges, right? Passes and then it diverges. Now here it is diverging. So what will the eye lens do? It will converge, right? It will converge, and you find that so the concave lens diverges, right? Whereas the eye lens converges, and because of which the rays of light meet exactly on the retina. And this concave lens, right? This concave lens solves your problem of myopia. Please refer to your figure number 11.2 in your textbook, and that will give you a clear picture about that, okay, in the diagram. Okay. Now we move on to the next problem of, or the next defect of vision, that is hypermetropia or farsightedness. It is just the opposite of myopia. Let me read for you. Hypermetropia is also known as farsightedness. A person with hypermetropia can see distant objects clearly but cannot see nearby objects distinctly. So hypermetropia means can see far or distant, right? Distant objects clearly. This is very clear, can see far or distant object clearly, but nearby objects, right? Nearby objects is not clear. It appears cloudy, foggy, or blurred, right? The near point for the person is further away from the near point 25 centimeters. Such a person has to keep a reading material much beyond 25. Okay, if you keep an object, for a normal eye, if you keep an object at 25 centimeter, you will be able to see it clearly. But for a hypermetropic eye, if you are keeping an object at 25 centimeter, you will not be able to see clearly. So you have to push behind 25 centimeter. Okay. This is because the light rays from a close by object are focused at a point behind the retina, right? So now in case of hypermetropia, what happens? If this is the retina, okay, if this is the retina and this is the lens, the rays of light coming from an object, right, what happens is they meet where? They meet behind the retina. You remember, in case of myopia, the rays of light meet in front, whereas in hypermetropia, the rays of light meets behind the retina. Now, why? What are the two or three problems? Number one, the defect arises. The focal length of the eye lens is too long. The eyeball has become too small. Right? Either the focal length, right? The focal length is too long, right? Or the eyeball, right? The eyeball has become too small. Okay, the eyeball has become too small. Too small. Okay. This defect can be corrected by using convex lens of appropriate power. So if you want to solve this problem of hypermetropia, you need to use what? You need to use a convex lens, right? What happens when you use a convex lens? When you use a convex lens, that means there will be a lens in front. So over here also refraction is there, over here also refraction is there, and then the rays of light will meet exactly where? Will meet exactly on the retina. So we have seen myopia, we have seen hypermetropia. Okay. Then the presbyopia. The power of accommodation of an eye usually decreases with aging. Please keep in mind, I like to inform you that the power of accommodation is really high in case of a child. Okay, a child who is born, just born, if the eye is normal, right, you find that the power of accommodation is very high. But as we grow old, the power of accommodation gradually decreases. That is what it is mentioned. The power of accommodation of the eye usually decreases with aging. For most people, the near point gradually recedes. They find it difficult to see nearby objects comfortably and distinctly without corrective eyeglasses. This defect is called as presbyopia. It arises due to gradual weakening of the ciliary muscles and diminishing flexibility of the eye lens. When your ciliary muscles, ciliary muscles is actually responsible for increasing or decreasing the focal length. Okay. Now with age, if the ciliary muscles if the ciliary muscles become weak, then the eye cannot adjust its focal length, right? And if it cannot adjust its focal length, then it will not be able to see clearly the objects which are either near or far away. Sometimes a person may suffer from both myopia and hypermetropia. We have seen, right? We have seen myopia separately, we have seen hypermetropia separately, right? So it is not that a person who has myopia cannot have hypermetropia, or a person who has hypermetropia cannot have myopia. There are cases where the person suffers from both. He can neither see the nearby objects clearly nor can see far away objects clearly, right? So in those cases, the person has to use a bifocal lens, right? That means he has to use a lens which is made up of both concave and convex, right? Remember, when you are using a bifocal lens, right, the lower part of the lens is convex. Now, bifocal lens, what do you mean by bifocal lens? Bifocal lens means a lens which is made up of both concave and convex, right? In your spectacles, you will have concave and convex both. The lower portion of the spectacle will have convex lens, right? Convex lens, that is to correct hypermetropia. These days, it is possible to correct the refractive defects with contact lenses or through surgical interventions. These defects of vision is also called as refractive defects. Why am I calling it a refractive defects, or why is the book talking about refractive defects? Refractive defects, why? Let me tell you that whether it is for a normal eye, the rays of light meets on the retina, right? But you will see that in myopia, the rays of light meets in front. The refraction, the focal length is too strong, right? Because of which what happens? The rays of light meets in front of the retina. So that is a refractive defect. The rays of light are refracting and meeting at the wrong place. In case of hypermetropia, the rays of light are refracting through the eye lens and meeting behind the retina. So that is why, since the defects of vision is to do with the problem with refraction of light, that is why it is called as what? It is called as a refractive defect. Okay.